Hey y'all, Data Guy here, and today I wanted to make a video on the age-old question of batch processing versus event streaming. And rather than me trying to push you in one way or the other, saying one is better than the other, what I really want to do is just take a step back and look objectively at both of these two approaches to, data processing, and give you the information about both, some example use cases, some common tools, some examples of where, streaming might do something better, batching might do something better. And so with all that information, I hope to give you the tools you need to make your decision of which approach is best for your business, for your use case, for your project, for whatever. So I hope you enjoy this video, and I hope you get some value out of it. And if you do, let me know with a little subscription or a like. That would be awesome. And so without further ado, let's get into it. And so what I'm gonna do is kick it off by actually talking about, what is streaming data? Is it really just fast batching? So streaming data transfer, and what everyone just refers to as, streaming, not Netflix, is the continuous transmission of data in real time as it's generated. And what that means is there's no delay, but let's say, you're a game company, your World of Warcraft, right? And you need to capture information around all of your player interactions. You need to say, hey, this player did this, therefore I need to upgrade or update his backend gold counter, right? And so, it could be for streaming, could be for a real world use case like that, where you need to, have data constantly moving through systems, constantly collecting information around player count, optimizing how many backend servers to spin up, and real-time monitoring as well. So, if you data streaming, another use case is, let's say, hey, I have a Kafka in this. So this is actually what I'm showing you here. So Kafka is a data streaming tool, but with data streaming, you would have something like Kafka monitoring, let's say the health of all of your backend load balancers. And so whenever one of those triggers a failure message, Kafka knows to say, hey, take that unintelligible, string of binary code, let's say, and, parse it into something human readable and then send an alert out. And that's honestly, and so that's like a very simple example, but most of the time it's going to be, whenever you have information coming in on an irregular but constant basis. So, point of sales, IoT devices, robots on a factory floor. That's where streaming data is most likely going to be used, because you need to have a constant flow of data. You need to be constantly analyzing that data, understanding, hey, are any of these IoT devices down? Are there any issues here that need to be addressed really quickly? Or you just need to constantly be optimizing, your trades, like in the stock market, right? And so, as you can imagine, actually being able to do all this real-time processing, especially on large amounts of data, is really, really difficult and computationally expensive. And so that's why there are a number of services that allow you to manage this and distribute that computing over a cluster of computers, so you can perform all these services in parallel. And so in terms of tools that you're going to manage this massive amount of compute, you have things like Apache Kafka, where you have this is an open source distributed event streaming platform where you can say, hey, I can have a ton of different computers always looking at, data stream, whenever a data point comes in, perform X amount of transformations on that data to conform it into, my schema, and then upload it in there. And then you also have another one, Apache Flink, which you guys liked as well when I made a video on that, where it is really, constantly as data is coming in, you're running a Python script on, you're running transformations, and it's never actually stored anywhere before, it's just data point arises, is transformed, is stored in a backend database. So in most data streaming services, you're going to have a source and a sink. And so a data streaming pipeline can't really run without a sink, because you need somewhere for that data to go, because the data streaming platform itself can't store that data on it. You're going to need to rely on, hey, just it's running that transformation and then putting it somewhere else. And that, that makes sense, because with the amount of computational, needed to actually run all these processes, potentially thousands of data points a second, it's much better to stay, have the actual storage of that occur elsewhere. So, most of your data stream pipelines are going to have that source and sink kind of methodology. There's also Amazon Kinesis, but I don't really terribly like Amazon Kinesis. So, if you're using all AWS stack, definitely try it out, but it's just personally not my favorite. So now on the flip side of streaming, I want to go into what is batching data processing and what is that really good for. And so Batch data processing, as the name might suggest, means that instead of transforming your data as it arrives, constantly moving, once a data point, comes about from your source system, storing in the backend after it's gone through some transformations, batching will say, hey, let's just wait for the system to produce X amount of data. So, an example here could be, hey, I have a point of sale in my coffee shop, right? And I don't care second to second how many people are buying it, but every day I want to collect a list of all of my customers, and I want to, trim the timestamps off because I don't care about that. I just want to store what their customer name was and how much they spent here, and then kind of try and correlate whatever. And so this is where you don't need real-time analysis, but you just need to have all the data available to then in bulk be analyzed downstream. And so you have that example of a daily sales report, but this could also be for like inventory updates, periodic data backups, where you say, hey, like a common strategy for databases is every day at midnight, take a snapshot of the data so that if something fails in the next day, you can revert to that snapshot. So that way, if your whole database goes down, you don't just lose all that historical information. And so really useful when you don't care necessarily about the speed of it. So it's much more efficient in terms of, because you're not running compute to constantly transform data, this is much less computationally expensive. But the trade-off was there is that, hey, you don't have that real-time updates. You have to wait for, your daily sync or whatever. And so in terms of kind of systems you might be using for it, honestly, you can be using most anything. Like you could even be using a Python script for your batch data processing. Airflow can do batch data processing. But there are also some, if you're dealing with terabytes of data and you want to do all that transformation within a single system, that's where you have tools like Apache Hadoop and Spark, which, and this is also, if you don't know, Spark and Databricks just manage Spark, where it can be used for streaming. You can see batch/stream data, but widely used for batch processing because it's really expensive to have a Spark cluster up and running all the time. So what a lot of people do is say, hey, on a daily basis, take the Spark cluster and do a lot of really fast analysis on this batch data that I've collected over the day. So you're just using that Spark cluster for a really small amount of time because Spark can process that data really, really fast instead of just, relying on processing data as it comes in and driving up your potential cost. If you don't need the real-time analytics, then there's no need for you to actually do that, right? And then also any traditional ETL tool you could also kind of think of as a batch process. Imagine you're taking a table from a database. That table is a batch, right? You're not streaming that data table by table. You're taking a data set, batch, moving it into another database. And so now we kind of giving you the tools here. Hey, what streaming is, what batch processing is, which is right for you. So I wanted to break it down into kind of 5 main categories. So we have timeliness, complexity and resources, data volume and velocity, fault tolerance, and just general use case suitability. So first, under timeliness, streaming is going to give you the most real-time data processing, obviously. So if you have really time-sensitive decisions, streaming is going to be much better for that. If you need to have a live report that's constantly updating you on information, if you have things where, hey, if a failure isn't noticed for 5 minutes, that's a huge problem. You're not going to want to do batch processing. You're going to want stream processing. However, if you don't need to have that real-time analysis, you don't need to constantly be knowing, hey, is this the right time to buy X stock or crypto or whatever? Batching is probably right for you. It doesn't require the need to have a system constantly running. You can kind of do it lazy Susan style, wait for that data to accumulate, then update it, while still maintaining the ability to do the same level of data analysis you would be able to do with streaming services, just not in real time. And so that kind of leads into the second category, which is complexity and resources. Streaming is infinitely more complex to, or not infinitely, but is much more complex to implement and maintain. Well, you can have a really easy to use streaming script that says, hey, take a data point and process it and then upload it into a database. When you have to scale that across, hey, I need to process thousands of data points at once, but I don't know when that's going to happen. It can just spike out of my control. Streaming has a lot more variables to account for. You got to account for that, variability in traffic. You got to have compute that can scale up and down dynamically to support that. Versus batch processing, you can say, hey, every time my data reaches a certain size, process it, right? And so you can kind of set those controls. It doesn't You don't need to have a big piece of data infrastructure constantly running. You can just run it when you need to run those transformations, generate those reports, and typically you can sit idle otherwise, right? And then next, we have data volume and velocity. So streaming is really ideal for high velocity data where the flow is continuous. And so velocity means the speed that new data is generated is really fast. So any situation where you have, IoT devices, they generate a data point about their status every second, right? And so in situations where you have just a nonstop flow of data that you need to be monitoring and plugging into your existing data sets to be able to say, hey, is this outside of the norms? Streaming is going to be really good for that. But it's not going to be really good if you have to, produce terabytes of data at once, right? If you have to process a terabyte size table, streaming pipelines are going to have a really hard time handling that versus batching. You can have, much more well suited to processing really large amounts of data in a small amount of time. And so that's kind of the differentiator there if you really want to boil it down to high velocity versus high volume for, hey, streaming versus batching. And then you also have fault tolerance. So fault tolerance, you have, streaming systems need robust fault tolerance mechanisms because you have a continuous data flow. If something screws up and you don't catch it, all that data can be corrupted and you don't know exactly when that change occurred. Versus batching systems can often manage with simpler fault tolerance solutions since you're doing it, once a day. Maybe you're looking at the report you generate once a day. It's easier to catch errors. That, hey, I can just quickly perform a diff between this day's data pipeline and yesterday's and see what the change was. And you can also use systems like Open Lineage to record that as well. So much easier to set up fault tolerance. I'd say it's equally important, but with streaming, you need to have a lot more time spent to it. And then finally, just on general use cases, streaming is really, really good for anything where you need like immediate data insights, you need a constant updating dashboard, you need a constant flow of data, like you're in the situation room and you've got all your data streamers coming out, they're coming out of the walls and they're giving you all that data, right? Versus batching is, hey, I have these really large reports that I know how I need to process, I know when I need to reprocess, it's not every day, and you can just kind of build a scheduled thing to, perform that action because it doesn't need to be super time sensitive. It's, maybe a weekly executive report, right? And so because you don't need that really time sensitive data, it's a lot easier to set up, it's a lot easier to maintain, and it's just a lot chiller, right? You don't want to chill out. So in conclusion, I think those are really 5 categories to kind of judge, for, hey, yourself, do you need to use streaming or batch processing? Because it will hinge on your specific data requirements. So I hope this video has given you all the tools you need to make that decision effectively. And if you need help making it, don't hesitate to reach out. I'm always here for advice. So have a good one. Data Guy out.